Okay, so number 10 I'm going to do with my vertex form. B is equal to negative 2. A is equal to 1. Negative 2 over 2 times 1. 2 over 2. X equals 1. Remember, this is my axis of symmetry, which is the same as that H value. So H equals 1. My K is if I plug in my X value to my whole equation, I'll get a Y value. So I'm going to plug in 1 into my equation. Which is 1 minus 2 minus 5. Which is negative 6. So I have 1 and negative 6 that I'm going to plug into my formula. X minus, make sure you're plugging it in for the H, not for the X. Minus 1. Plus K, which is minus 6. My A value is 1. So f of x equals 1 times x minus 1 squared minus 6. Number 11, graph and state the solutions. To graph your quadratic, you're going to do your axis of symmetry. My B value is whatever my x term, my coefficient of my x term. Do I have an x term? No. So my B is 0. My A value is 1. So my axis of symmetry is 0. So my vertex, I'm going to plug in 0 for x. 0 squared is 0, minus 9 is negative 9. So my vertex is 0, negative 9. I'm going to plot that. It's 1 off of this grid. So I'm just going to plot it 1 off. And then I could start plugging in values for my vertex, or for my function. So 0 and negative 9 is one of my points. I can do negative 1, negative 2, maybe even more than that. Positive 1, positive 2, positive 3. If I plug in 1 to that formula, do f of 1 equals 1 squared minus 9. F of 1 equals 1 minus 9, which is negative 8. So negative 8. F of 2 is 2 squared minus 9. F of 2 is 4 minus 9, which is negative 5. And f of 3 is 3 squared minus 9. So f of 3 is 9 minus 9, which is 0. In the opposite direction, I can use my vertex for my symmetry. So I have negative 9 here. This is negative 8, so this should be negative 8. Negative 5 and negative 5. And I should have negative 3, 0, because I have positive 3, 0. Plot each of those points. So over 1, down 8. Over 2, down 5. And over 3, down 0. Same thing on the other side, axis of symmetry. This is 3 away from my y-axis, so this should be 3 away, 2 away, and 2 away, 1 away, 1 away. Then I can start graphing my linear equation of g of x equals x minus 3, where negative 3 is my y-intercept. So I go down 3, 1, 2, 3. My slope is in front of x, so my slope is equal to 1, so I go up 1 over 1. Or down 1, back 1. So all of those points from negative 3, up 1 over 1, or down 1 over back 1 would be my g of x, and my quadratic is my f of x, and they cross at 3, 0, and negative 2, negative 5.
Basically, microeconomics.
13. These are easier to see because they're already graphed for you. They cross right here at 2, negative 1. And up here at negative 3, 4. So my solutions are negative 3, 4, and 2, negative 1. If you just had to write the x value, you would say solutions when x equals negative 3 and x equals 2, because those are my x values at those solutions. Over here, my points are 2, negative 3, and negative 3, negative 8. And so those would be my two solutions, or whenever x equals negative 3 and x equals 2. So both of those were the same x values, I just got some different y values. Number 14, solve for x, leave in radical form. Whenever you see an equation equal to 0, your gut instinct should be to do the quadratic formula. Where a is equal to 1, b is equal to negative 4, and c is equal to 1. So it should be negative, negative 4 plus or minus negative 4 squared minus 4 times 1 all over 2 times 1. 4 plus or minus 16 minus 4 over 2. 16 minus 4 is 12, so I'm going to do x equals 4 plus or minus the square root of 12 over 2. Now, this is radical form, and it did not say simplified radical form, so I would say that that is an answer. If your teacher wants it in simplified radical form, I would have to factor the number 12 to 2 times 6 and 2 times 3. I have two 2's, so I can bring a 2 out to the front. Now, both parts of my addition problem or my subtraction problem have a multiple of 2, so they can be reduced. So I would get x equals 2, because 4 divided by 2 is 2. 2 divided by 2 is 1, so I'm going to have plus or minus 1 root 3, which is the same as square root of 3. That's a way to solve using quadratic formula. You could also solve by completing the square, and I'm going to show you that for number 15. If I were to complete the square, I would move the 7 to the other side by subtracting. So I would get x squared plus 4x equals negative 7. My number that is missing is my c value to make it a perfect square. Remember, I split up my 4x evenly, so 2x and 2x, so that will give me x plus 2 and x plus 2. 2 times 2, my missing number is 2 times 2, which is 4. I add that to both sides. Negative 7 plus 4 is negative 3. the left side factors to x plus 2 squared. I can use square roots to solve. So I get x plus 2 equals plus or minus the square root of negative 3. That can be simplified a little bit more because I have a negative on the inside. I'm just going to go ahead and do that at the end after I subtract my 2 from each side. Remember I said that this could be simplified more. The negative means I can bring an I out to the front. So my answer would be negative 2 plus or minus I root 3. That's my answer. Number 16. Simplify. This breaks up into square root of negative 1 times the square root of 4. Square root of 4 is 2. Square root of negative 1 is I. So I get 2i. Square root of 4 is 2. Square root of negative 18. I would have to factor that because it breaks up to square root of 1 and square root of 18. This factors to 2 times 9 and 3 times 3. I have 2 3's, so I can bring 1 out to the front, but I'm left with a 2 on the inside. But remember, square root of negative 1 equals I. So 3 on the outside, I on the outside, the square root of 2 left. F, I would do the square root of negative 1 times the square root of 50, but if I know the perfect square that factors out of 50 would be 25, then I can break it up to the square root of 25 and the square root of 2. Square root of 25 is 5, square root of negative 1 is I, and the square root of 2 is the square root of 2. This breaks up to the square root of negative 1 and the square root of 9. Square root of 9 is 3, square root of negative 1 is I, so 3i. This breaks up, well, the square root of negative 1. We already know what that is. That's just I. I times I would give me I squared. And that would be like writing the square root of negative 1 squared. The square root cancels out the square cancels out the square root. And I get, because they're inverse operations, my answer would be negative 1. And I kind of went in a roundabout way, but for C, it would also break up to the square root of negative 1 times the square root of 11. Square root of negative 1 is I. So I would get I root 11 because 11 is prime and cannot be reduced anymore. Number 17, I just have to plug in the correct A, B, and C values for part A of my equation. So A equals 3, B equals negative 5, and C equals negative 1. So I write negative 5 plus or minus negative 5 squared minus 4 times 3 times negative 1 all over 2 times my A value, which is 3. Then down here I have to solve. So negative 5 would be positive 5 plus or minus the square root of 25. Negative 4 times 3 times negative 1 would be positive 12. All over 2 times 3, which is 6. So 5 plus or minus, that would be 37. All over 6. And you should be leaving this in simplified radical form. Which would be this answer here. X equals 5 plus or minus the square root of 37 all over 6. 37 is prime, so I can't reduce it more than that. Number 19, axis of symmetry. I'm doing x equals negative b over 2a. My b is 100, so negative 100 over 2 times negative 16, which gives me negative 100 divided by negative 32, which is a positive 3.125. So x equals 3.125. This did not say where to round, so I'm going to leave it like that. My vertex, that's going to be the x value of my vertex, so I can already write that down, 3.125. And then I'm going to have comma, some y value. I'm going to plug in my x to find my y. So I do negative 16, 3.125 squared, plus 100 times 3.125, plus 84. I'm going to square 3.125 first, which gives me a very long number, which I would keep in my calculator, and just multiply that by negative 16 whenever you actually are solving. But since you need to see what's going on, I'm just going to write all the values down, and if it asks me to round at the end, I'll round at the end. You can start simplifying this part if you would like, but I'm going to multiply by negative 16, and that gives me negative 156.25 plus 100 times 3.125, which is 312.5. Then I add all of those together, and it's going to give me my x value, which is 240.25. Oops. My solutions are talking about my zeros, or my x-intercepts. So whenever my equation equals 0, so I need to use my quadratic formula. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. I'm going to continue this on another piece of paper so that I have enough room. Negative 100 plus or minus 100 squared is 10,000. Negative 4 times negative 16 times 84. Multiply those all at one time. 4 times 16 times 84. Where did I get a positive from? Negative times negative is a positive, so I want to make sure and check that while I'm going through. And 2 times negative 16 is negative 32. This is to find my x values for my x-intercepts, so I do negative 100 plus or minus the square root of 15,376 all over negative 32. The nice thing is, even though that's a huge number, it is a perfect square. So if I take the square root of that, 15,376, I get 124. So this is x equals negative 100 plus or minus 124 over negative 32. So I split that up. Negative 100 plus 124 over negative 32. And negative 100 minus 124 over negative 32. This gives me 24 over negative 32, which is 0.75. Negative 0.75. And this gives me negative 224 over negative 32, which gives me positive 7. Ooh, you couldn't see that, could you? Let me remove that up. So I did negative 100 minus 124, negative 224. Negative 100 plus 124 gives me positive 24. So divide those, and you should get these two numbers. So I'm going to go back and write those as my solutions to my problem. X equals negative 0.75 and x equals 7. And I believe that was the last of those problems. So good luck. Make sure you go through this video and pause when you need to.